Hi, so today I'm going to work on a project to create an AI which can play Flappy Bird. Firstly, the AI is going to need a game to play, and seeing as Flappy Bird was removed from the App Store in 2014, we'll have to start by creating the game itself. To create the game, I'm using Python and the Pygame module to display the graphics. First off, we're going to create the pipes, which will have a gap at a random height and will move towards the left of the screen with a constant velocity. Then we'll add a bird, which will have a fixed x position. There will be a constant gravity force which acts on the bird's velocity each frame. Then we'll add a jump function which applies a force to the bird so it can manoeuvre through the pipes. This is the basic game created. It certainly doesn't look pretty, but I think it might be easier to test the game like this, so we'll go with it for now. The idea of this project is to create an AI which can play Flappy Bird, so now we need to give the birds some AI. I'm going to be using Neuro Evolution for this project, which is a combination of neural networks and genetic algorithms to allow an AI to learn over multiple generations. Each bird will have a neural network which will take in inputs from each frame and calculate an output. First, we need to define what each bird can see, which will be the y velocity of the bird, the x distance to the next pipe, the y distance to the top of the next pipe, and the y distance to the bottom of the next pipe. Each frame, these values will be passed to the neural network as inputs, which will give an output value to determine whether or not the bird jumps. Although it may not seem important, the y velocity is vital to this AI. Looking at this frame, we'd think the bird should jump, but there is nothing to tell us whether the bird is currently moving up or down, or if it jumped on the frame before. By giving the neural network its y velocity, it can make different decisions based on how it is already moving. Then we need to add the genetic algorithm. First, we need to define a fitness function which rewards birds which do better. We'll do this by increasing each bird's fitness for every frame it's alive. Once the whole population has died, parents are randomly selected from the previous generation based on their fitness. This means that a bird which survives for several pipes is much more likely to pass on its genes to the next generation than one which crashes straight away. With two parents selected, their neural networks are combined to create the neural network of the child. This is then mutated, which allows for variation so the new generations can develop new behaviours which weren't present in the initial population. With that all done, let's watch this AI learn to play. In the first few generations, there is a lot of variation and many of the birds crash quickly. A few of them have good enough neural networks to survive for a few pipes. This one's doing well, let's speed it up. This jump proves a bit much for this bird. There's not much improvement until generation 9. This one's doing well. This doesn't look good. By generation 13, this bird has learnt what to do. I think we might be here a while. I've built in a feature so we can run the training at 50 times speed. Let's speed this up a lot. Well, that's 10,000 pipes. I think we can say this one has learnt to play Flappy Bird. I've really enjoyed working on this project to create an AI which could learn Flappy Bird. Having neural networks which evolve over time to learn by themselves without needing to be told what to do is impressive. I have some other projects planned with Neuro Evolution, but if you have any suggestions, please let me know. If you enjoyed this video and want to see when I complete my next project, feel free to subscribe. Thank you, I'll see you next time.